All right, everyone, let's come back together. Once again, my name is Kwong, and we're going to spend some time talking about APIs and promises before lunch. So lunch will be at 12:45 today. So in the past few days, we've been working on a lot of things. We've learned about HTML, CSS, and we've made this really nice catbook website. But it doesn't really change with user data. Like every time you go to it, it's this corgi. And why is this? What's missing? Well, it turns out that this whole time we've been working with the front end, which is the part that users directly interact with. But there's actually another half of web development that we haven't really talked about yet. And that's the back end. That's where the data is stored, data is manipulated, and all the other things that happen in the background happens. And here we have a picture of a server room, but anything that does this can be a backend. The backend could be on your computer too when you're developing later during the workshops. And in this particular lecture, we're not going to focus as much on the backend, how the backend works, but more on how the front end interacts with the backend. And before we get going, let's get some terminology out of the way. We have client, which is just you and your teammates' browsers on your computers or your phones. And these are called clients. Whereas the devices that hold your site's information is called the server. And every time the client wants to get information from the server, it sends a request. And then the server responds with a response. So how do we actually send information? Sometimes you're going to be accessing information from a server miles away or across the globe. Well, email is not the answer for this. And it has to do with a specific type of request and response. And you guys have definitely heard of this before. It's called HTTP. So what is HTTP? It's short for Hypertext Transfer Protocol. And if you recall, HTML actually also has the word hypertext in it. So HTTP was originally made to transfer hypertext to send HTML and that sort of thing around the net. And now we use it for sending and receiving all sorts of information. You've probably also seen HTTPS, which is just HTTP plus secure. So let's spend a little bit of time looking into how this HTTP request is actually structured. So breaking it down, we have the request target, method, headers, and body. And now let's go through each of them individually to see what is happening there. So first we have the request target, which has the URL and the query parameters. So in this example, I just went to YouTube and I typed in WebLab on the search bar. And this is what the URL link on the top of Google Chrome said. And this is basically how request params and target is structured. You have the URL, and then you also have query params behind it, denoted by or prepended by a question mark. And of course, in the beginning, we have the protocol, which was HTTPS. Now let's look at the methods. So you guys might not have heard of this one before, but it kind of indicates the desired action for your request. So get, gets data, post sends data, and this often creates change or gets or creates new data on the server. Put is used to replace data on the server, and delete is to delete. And for the purpose of WebLab, we're probably going to focus most on get and post. There are also other methods. There's a few more. You can read about it in the Mozilla MDN docs. So the request also has headers and body. The headers are used to provide context for the HTML request. And in last year's lecture, they called it the fancy stuff. And I think that's a pretty good description of what's going on. And the body is the data associated with the request. So for example, if you were making a post request, trying to add a new user to a server, then you probably have information about that user, like their name or their phone number or something like that. And something to note is that most HTTP requests that you will be working with in this class or in this competition will use a notation called JSON. And you'll see this later on during the workshops. And JSON is just like JavaScript objects, but formulated to be a string. So to recap, the request has the target, which also includes the query parameters. We have methods like get or post, which indicates what you're trying to do. Headers, the fancy stuff giving context to the request. We might talk about more later, but don't have to worry too much about this part. And the body, which is the meat of the request, like the data that you're trying to send and whatnot. But let's move on to the response. We've sent a request to the server, and it's going to give us back a response. So the main components of a response are the status code, the headers, and the body, which is somewhat similar to the request. And again, we'll go through the parts individually. So status codes. You guys have probably seen this before, even if you don't know what this is. And those are things like 404, like that the web page was not found or the resource was not found. 200, which is just like, okay, that it was successful. 500, which means that something broke in the server. Or like 400, which means that you probably formatted your request incorrectly. So there are a lot of status codes out there. Usually the ones that start with 200 mean that it was successful. The 300s means that you're getting redirected or something didn't change. 4 is some kind of error on your end. And 5 is that the server is just like broken. And we were talking about the response components. So we have the headers. And again, this is like the fancy stuff, information about the response, like the content type of what response the server gave to you. And we also have the body. This is the information that you were trying to get. So for example, if you were trying to get information about a user, it would tell you their name, phone number, and whatnot. And this would be usually, again, in JSON format. So to recap, the response has a status code, for example, 200, 404, headers, some details about the response, and body, which is the meat, what you were trying to get. So let's pause for a second. See if does anyone have any questions? Screen's orange. Screen's orange.
Yeah. That might be the HDMI connector then.
No, it might be my screen. Okay, I don't know how to do this. I think the screen is a little yellow. You're right. Yeah, so the request is what you send to the server, you as a client using your computer. And a response is what you get back from the server. All right. And servers can send requests to each other too, or requests to another server and get a response back. So this whole time you've been using Google Chrome to go to websites and for other browsers, and your requests have been mostly out of sight. And it turns out that a couple of days ago, we were using inspect element to try to figure out what was happening on a website. You can use this to see what is happening with the network too. So for example, if you just open a page like catbook, which you can go to with weblab.is/example, and then you went to Google Chrome, you did inspect element by doing right click and this inspect button. And then you can go here and click on network. This is a tab that we haven't seen before, which is where all the HTTP requests that you make are stored. So let's try going to weblab.is/example, which is going to be the final catbook that you make by the end of this lecture series. And maybe the server is a little overloaded and we did not pay Heroku enough money. Okay, so Cap looks a little broken right now. But we can do this process on any other website. So if I go to web.mit.edu, oh, not that one. You can see all the requests that were made. So for example, here we made some requests to a picture of Tanzania. It responded with 200 OK. This was a GET request, and the content type of what was returned was like a JPEG. You can see what kinds of APIs are being called, maybe like explicitly define the API, guess not. Yeah, fun place to go is like to try to look people up. So I'm going to try to look up Kenneth. And then you can go people. Start. Okay, you see Nicholas or Nick Sal, and you can actually use this networks tab to see like what this MIT website is doing in the background. So if I type in like NT Sal here, they're actually calling a bunch of APIs to get this information about Nicholas or Nick. So the client, which is you on your browser using your MIT website, is calling an API at this place. It's a GET request, responding with 200 OK, and that gives us the information about Nick. Strange. Yeah. Very cool. So enough about inspect element. Let's go back to here. Something to note is that when you type any URL into the browser, this sets off a GET request that often responds with like HTML, CSS, and JavaScript in the example of websites. But for some things like a direct call to wherever they were getting this information about Nick, it will just do a GET request and respond with some JSON, which is similar to JavaScript objects. So any questions? All right, moving on. So let's learn about APIs next. So what are APIs? APIs are application program interfaces. And that's just like a fancy term for a set of endpoints of a service that you can make requests to. So companies, Google, Amazon, Facebook all provide APIs so that other people can use their services. But like, why do we actually need an API? And that's because we as like clients or us building our servers need access to other data. But we can't like just go into Google and be like, yeah, give us all this information about all your millions of users, because that would be really inconvenient and a security nightmare. And Google also doesn't want us to like know what they're doing. So APIs provide structured places for us to send requests to. And these places we call endpoints. So now you can do a bunch of stuff by asking the right people nicely. And this is just like a visual description of what an API is. So the API and the data would be on, for example, Google side, and all the clients would be us asking information to this API and getting a response. So endpoints, every time you access a URL, you're actually making a request to some kind of endpoint. And in the example of Catbook that we were trying to use, if you go to catbook2023.herokuapp.com/API/stories, this is a GET request for all the stories on the site. Whereas if you make a post request to /API/story, you can make a story, because if you recall, GET is used to get information and post is to like send information and make some kind of modification or addition to the data on the server. And another thing to note that you will see later on during the workshops is that multiple endpoints under the same URL can have different kinds of requests. And that would be defined using the HTTP method. So for example, with /API/comment, you can either use a GET or a POST to get information about comments or make a new comment. And you'll see more of this later in the workshops when you start building your own APIs and calling APIs. So there are a ton of APIs out there. I said that companies use APIs to let you like get access to their services without knowing, to abstract away like what they're actually doing. So some cool API examples that you can play with, for example, are like Open Weather, Dog API, which is just like information about dogs. Google Maps has an API that lets you like just input coordinates and get information. Twitter is cool. Twilio, you can like make a text bot, and of course, OpenAI. And before we were using MIT to like look up Nick's like information, how he's course 6. This stuff was using an MIT People API. Yeah. So one thing to note is that many of these external APIs, I mean, they don't want you to just like use their services for free, and they'll give you like some kind of API key. So just be like a bunch of numbers or like the long string, and that you will include your requests, either in the params, the body, or the header. And that will like identify you to the service, and they can either rate limit you or charge you for what you're doing for using their API. So since we've learned about all these cool API examples, let's take a moment to like try to like test out using one of these APIs and try to like read some documentation to see how we would go about like using one of them. And for this demo, I'm going to use a tool called Postman. Postman is something that you can download to test out APIs. And it's really nice because when you start building your own APIs on your own local computer, you can call those APIs using Postman. And it'll be easier to debug than if you like just like opened React and started like calling the API, because you don't have to type out all that code. If you want to do stuff on your browser, you can also go to recbin.com. So I do have Postman downloaded here, and we'll be using this for the next demo. And I was trying to choose which API to test out. And since our theme is you and I, and Nick is literally a bot, we will try to play with the OpenAI API. So I'm going to open this up. And we see that, get rid of this. OpenAI gives us a lot of models, really cool stuff like GPT, which you guys have probably heard of with all the stuff going on with like ChatGPT and whatnot. And also like some models for like doing image generation and stuff. But this is really cool because you can like, this chat GPT is basically like some kind of like chatbot. You can give it some input and it will give you a response. But this is not the API reference. This is just like the models that they have, which you can look into and use in your project if you're interested. Let's look at the actual API reference, which you will be using to like call the services or to call this API. So looks like we are in the authentication section. They're telling us some stuff about how we can use API keys for authentication. And here they're saying that you want this like API key to be in your headers under a place called authorization. Making requests, okay. Looks like they have an API endpoint called /mottos, which you can get to get their list of mottos. And another one for like completing an input. And it tells you what it wants in its request body. So this is like the schematic for how you're going to use their API, which we're going to put in our HTTP request body. So for example, it wants the motto name as a string, the prompt as a string, and some other optional parameters like temperature, which is like the entropy or like randomness of the generated value, max tokens, the number of words. And yeah, like most of this stuff is just like reading for whatever service that you want to use. Another thing to note that is that apparently OpenAI makes you pay for what you're doing. And I've sent like a bunch of requests and now I owe them like 2 cents. So that's why I needed to set up like the API key here. But that's not the point. Let's go back to actually trying to make this request. So I'm going to open up Postman here. So in Postman, you can just like click this add button and make a new request. You can choose the HTTP method to use. So there's a ton of them, but most of these APIs would probably be using get or post. The URL, you can put in the params. Under authorization and headers, you can change that stuff. And the body is where you're going to put in the information that you want. So I've already entered a little bit of stuff in this OpenAI API. They want you to do a post request to /completions. So I put that in, and you want to specify using JSON format, which I've chosen here, the type of model and what kind of prompt to hand them, and whatever other parameters they want. So here I've said that, pretend I'm a robot named Iris. Can you teach me how to learn web development? So I'm going to click send, and this should send a request to the OpenAI server. And I did put in my API key already. So yeah. So it looks like we've gotten a response. It was a 200 OK. Interestingly, it took actually 6 seconds, which means that they were doing a ton of stuff behind. Maybe they were like spinning up some GPUs, doing some like computation. But let's look at the response. This is also a JSON format. We have information about the model, object, and we see what it has responded. Sure, learning web development can be a daunting task. Once you feel comfortable and confident, very cool. And again, you can like try a ton of stuff like, I'm hungry. What should I do? You can make yourself a snack, go to a restaurant. Okay, cool. So yeah, this is how you are going to make all API requests on Postman. And later we'll get to actually making API requests from your code. So now that we've learned a lot about requests and how to use APIs, how to like test them and what kind of APIs are out there, let's actually think about how to make them in JavaScript. So in this class in Web Lab, we've actually given you a couple of functions called get and post. They're actually written using the JavaScript fetch method, which you can like read more about from the MDN docs linked over there. But if you just want to use some like JavaScript methods, you can just use these two out of the box. So get, for example, of course, is a get HTTP request. You give it the endpoint and the parameters the query parameters that you want to put at the end. And also post, which you give an endpoint and also give it some parameters that you can put in the body. And you'll see more about how this is used later today in the React lecture and also during the W3 workshop. But hold on a second. If I try to like make this user object or user variable, and by setting it equal to a get, like a call of this get function, and I try to console log it, it says object promise, which like doesn't make a lot of sense. So it turns out that the return type of the get function is actually a promise. And don't worry about this phone number. Apparently it's Rafael Rey's phone number. So what actually is a promise? Like get and post are returning promises. Like what? This is so weird. So let's say you're hungry and you want to go to the Web Lab restaurant and you go tell the staff, I want a steak. And they say, I promise I will try to make a steak for you. So one of two things could happen. They could make a steak for you, it could be good. Or like bad things could happen. So the difference between these two is that either the promise was fulfilled or it was rejected. So let's think about why like promises are actually needed. Like, sure, like the promise can be fulfilled or rejected, but like why? Why does this like matter for a coding perspective? So most of you guys have probably taken 6100A and like know a little bit of how Python works, where you like go line by line and do everything. And this is like a synchronous process. This is like if you were working in the home kitchen and you wanted to make steak yourself, you're gonna have to like do everything one step at a time and then actually cook it. So you're like one thing trying to do all these things. And you're like your own client, you're like making food for yourself. But for web lab, we need something more advanced, which is an asynchronous process. So we have the web lab restaurant staffed by all these cool people and all of you guys who are going to go to the restaurant. And you're going to submit a bunch of orders, and you're going to submit these orders to the restaurant. Like, I want steak, I want pork chop and whatnot. And every time you submit one of these, you're going to, from your perspective, you're going to get a promise that we will try to make the food for you. And then each of these people will try to make the food. So one thing that's important about promises is that the clients are now able to do things while they're waiting for their food, because it takes time for like us to make your steak and whatnot. And on the other hand, from our perspective, like the server's perspective, we can like take these requests and divvy them up among the different people. This is also really important because like it takes a long time to make the steak. So you don't want to be like having code that goes line by line, because while you're waiting for your steak, you're not going to be able to do anything like use your phone. So promises allow for asynchronous processing. And more on how like async actually works tomorrow. Let's see how promises work in JavaScript and why like this asynchronous thing actually works in a code example. So before we're using get, which returns a type of a promise, if you want to actually get the value for like what is returned by get, then you're going to have to append it with a .then. And .then takes a callback function with a input value, so input parameter, and then you can do something with that parameter. So for example, you can set the state using what was responded to get. So a thing that's great about this is that when you're running get, when you've written this line, it won't stop like the lines of code underneath from running. The function, the callback function inside then will run only when you get back this API/stories response. We also have to handle the example where like your state gets messed up. So if this API/stories endpoint doesn't work and you get an error, so we can handle that by adding something called catch, and which takes a callback function with one parameter called error, and then you can do something with that error information. So here we're console logging it. And this notation may seem a little weird, but it is how promises work in JavaScript. And let's look at a code example to see like this asynchronous thing in action. So I have a promise called my 1 second promise. It just like becomes fulfilled after exactly 1 second. So we're using it by doing .then, passing it a function that would console log the value once that promise is fulfilled, and also trying to catch the error if the promise is not fulfilled, and which also console logs the error. And then we have some code underneath doing like a bunch of math and printing some stuff. Let's see what happens when we actually run this code. So it looks like the code underneath ran before. We see, hello, the circumference of Earth is something kilometers and hello. And then we see promise fulfilled with value, hello. And that doesn't seem to make sense because this like hello thing was, this promise was defined in line 11, and this other stuff was underneath in 16 and 17. But this is exactly what the value of promises are. Before we saw in the OpenAI example, it took 6 seconds, 6 whole seconds for us to go to the OpenAI server, ask them for some stuff, spin up some GPUs, and get a response. And you don't want that holding up the rest of your code. You don't want your website to completely freeze. Users won't be able to press buttons. And that's why we have promises. Promises let you indicate what happens when that request is returned, or like when something has completed asynchronously. And you'll see more of how this is used in today's workshop later, and also more advanced uses of promises tomorrow in the server's lecture. So in Web Lab, we say that you get free lunch with every lecture. This is actually a promise. Like You don't know if it's been fulfilled or rejected yet. But you can take a look at this code while you wait in line for your food and be back by 11:15